welcome back to my channel, and today we will solve like the typical problem which is the combination between the binary search tree and then that is the combination with the heap or the priority queue. And yeah, but so for today we can use a queue, or we can just sort the array, it depends. However, like in here, let's look into the problem, and this problem is like it is in the weekly contest before. Yeah, and there's no like the editorial for this problem, so I think that like there's so many interesting approaches for this one. Yeah, so our task is like we are given the queries, and then so we need to find some kind of the upper bound and the lower bound for the queries. So however, like in here we are given the tree. However, but we can simplify the problem because this one is a binary search tree, and then somehow like if we can traverse, we can perform the in order traverse, and then somehow like we can get the sorted array. For example, for this for the first example, we can have like 1 2 4 6 9 13 14 and 15, right? So for this one, like we are given the queries of the value of like 2 5 and 16. So if we look into this problem, so if we just look into the array, and if we assume that this two array is sorted, and then we get very nice observation here. For example, like for each value in the query, we can initialize the upper bound and the lower bound for each element. So for example, like in here we have the 3 queries, and then so we can initialize the -1 -1 -1 for all of them, right? Yeah, so in here, like what is how can we deal with this problem? And the first thing is that like this is the value from the tree, and then we keep traverse the I mean we keep iterate through this array. For example, like we are here, and then we also keep another pointer here, right? And then so for example, like this one denotes for the value of 2, and then so for the first element, this is smaller, 1 is smaller or equal than 2, right? We will update this one as the 1 and -1. Okay, so how about the next iteration? Next iteration we will move it here, and then so this value is smaller, the 2 smaller or equal than 2, and then because like this one can be the upper bound as well. So here like we can update this bound. So here that is the 2 and 2, right? Okay, so when right after we find the upper bound, we should like jump into the next element in the queries, because we are hoping to find the smallest upper bound and the largest lower bound. So that is the reason why right after we found the largest lower upper bound, smallest upper bound, we should move to the next element in the queries because it has already been satisfied, right? However, like we have one observation in here. For example, like let's say this number 2 is the value A, and this 5 is the value B, and let's say that this is I have the value in here is a C, right? Okay, so we have observation. For example, like in here, let's say that A greater than C and B greater or equal than A, because I assume that all of the things here are sorted. So it means that like the element in the later part will be larger than the former part of the array. Okay, so we can conclude that like B always greater or equal than C. So what does this mean? This means that we always can initialize the lower bound of the next index here using the lower bound of the previous query. So we will put it here, that would be 2, right? And here we can put that is -1. Okay, so however, like is there any kind of why don't we use this one? Okay, so the explanation is that if you look into this one, and let's say that this one is the D, right? And then let's say we have A smaller than D, and then A smaller than B. We cannot guarantee that the relation between the B and D. We cannot know the relation between them, so it means that we need to perform the comparison, right? Okay, so D in here, it is exactly the next, I mean the upper bound we found in the first array here, right? Okay, so because like our pointer for the first array is stop at 2, and then we can compare 2 with 5, it doesn't work, right? So we move it to the next one. Okay, so we can see that in this one it is like smaller. We can see that 4 smaller or equal than 5, and then we update the array here, that is the 4 and then -1, because the condition of the upper bound is not satisfied, right? Okay, so and then we move here. Okay, so when we can see that 6, that is greater or equal than 5, this condition is satisfied. So that's why we can update this one as the 4 and 6, because this one we found the upper bound, right? And then we move to the next one. We can move to the next one here. We move to the next one, and by initializing the lower bound of this one as the 4, and then we have -1, and when we keep traversing and keep iterate, and then we can gradually we will find that like that would be like 15 and -1, right? So here like we will have the final result as 2 2, and then that is the 4 6, and then this is like 15 and -1. So this is exactly our answer. Okay, this is exactly our answer. However, the most important condition in here, that is like these two arrays need to be shorted. Okay, so here like this one we can get by in order traverse, while this one we need to short it. Yeah, so that is the approach, and then so let's do it together. Okay, so in here, because like the definitions of the tree is too long, so I remove it. So for now we can have the array for to store all of the node value, and then so here like we need to use the default search to find all of the, retrieve all of the values in the tree. For in here like we get the root, and then I will get the root values, and okay, so this is the conditions for us to terminate the recursion. So if that's one, we return, otherwise yeah. So for the DFS, you just think that like if you want to traverse, and then so you will put like the order of the node you want to get the value. For example, like in here we will get the smallest value first, right? Because this one is a binary search tree, so it means that the left one is always smaller than the parent, and then the right one always like larger than the parent. So let's say that in here we want to have the shorted array here, right? We always get the node on the left first, right? So here like we just call the DFS of the root.left, and then we will give them the red values, and then for if it's returned, it means that all of the nodes on the left are processed, and then we will get the get the array, get the current nodes, right? So here we will get the root value, and then we get the DFS of root.right for the red values. Okay, so let's return. Okay, so here like let's say that we have the DFS of the root.file. Sorry, root. This one is the node values. This one is not the red. We need to initialize the root value first. Yeah, we initialize it. So let's return it to check. Okay, so we can get all of the values in here. So let's move forward. So for now, let's say that we will get the red array, and then we initialize for the first value as the, like, because we don't need to initialize all the things at once, so we just need to initialize the first element, and then we initialize this one first, and then we can gradually get this one later by using the recursion in here. However, in here, like, we will like do it by iterations. Okay, so is 0, for example. Because our queries are not shorted, so we need to short our query as well. Because like the most important condition is here, like, let's make sure that it is shorted. Okay, so the queries, it is no guarantee for the query is shorted, or here like there's no information about that, so we need to, however, like when we short, and then they force us to return the answer in order, so we need to preserve the index by using some kind of the we need to preserve the index by introducing index with the queries together. So we can put this as the queries of the index, and query of the index, and then we also embed the index in here as well, and then we will have the queries. Okay, so let's see the queries. Yeah, so 2 at the position 0, 5 position 1, 16 at position 2. So for the first element, we will preserve the value of the query, while the second one will denote for the order. We can make use of this information later to, like, get the result. So let's see that, like, we have the answer, and we will initialize for all the things, because like the answer will have the equal length to the query, so we will get the queries. So for in queries, and then we have the red array. Because like in here, like for any new element, and then we somehow, like, we always get the result from the previous element, right? It means that whenever you come here, and then you always adapt to the lower bound of the previous query. So here, like, we red array here, that means that, like, okay, so here, like, that would be like temp array. That is not, should not like make them confused. That is the temp. Okay, so this is temp. This means that next element in the temp array. I mean the last element 0, and then so we should like put this one as, because this will have 2 elements, right? -1. We initialize the new value for example, if we next into this value, we will like initialize like 2 -1. Yeah. So for any time we need to update the answer as well. Num of 1, right? Because here, like, we get the position. So position equal to value. What is the value? That is the temp of array for -1. Okay, so for now, like, I will use the iteration here. Well, I is smaller than the length of the node bounds. We will go through all of the node bounds, and then if the node bounds of I, if that is smaller or equal than num0, right? No, not the num0. So here this is the num1. Okay, it means that, like, yeah, our queries is here, so it means that we are comparing between this array, this is the num, and this one is the node bound, right? So here we can see that, like, if what if we find this one is the lower bound, and then so we need to update this, right? Zero, it means that we update this one. And then what if, and then we only need to get the answer of num1 equal to 10th array of -1. Only update the latest one. If not vals of I greater or equals in number of 0, and then what should we do? We will get the temp of array -1 0, right? And then so that is, so not also 0, we in here and should be 1. And then so we need to get the node vals of I, and then we will get the answer num1 equal to 10 of the array -1. Okay, so whenever we find the number for the upper bound, we should like break, right? And otherwise we will get the increment the I by 1. Here like we will get the answer. Okay, so let's check. So here like we get the we update the lower bound, we update the upper bound. Okay, it looks good. We forget to get the queries short, because like in here like we will require 2 arrays are sorted, right? All right, we are here. So yeah, so I think this is the way for us to solve the problem. So thank you for watching. Yeah, I think that's all, and thank you for watching my videos. And if you like, and if you want to give me motivations to continue to do more videos for you guys in the future, please give me the subscribe or put the comments or like the problem you want to discuss with me. Yeah, so I think that's all the things we have for today. Have a good day and goodbye, and see you next time.